Hey there, this is Math 8, Unit 5, Lesson 11, just the extra homework practice stuff. This one's on filling containers. And as always, the first problem is always a cool down, somewhat of a review for what you did in your lessons. So I try not to do those ones, but maybe we'll talk you through them a little bit rather than give you the solutions. So here we go. First it says two cylinders, A and B, each started with different amounts of water. Okay, so we can see over here at a graph with A and its height in water here and the height in water there. We could make it up just if you wanted a number. Maybe this is 10 centimeters tall and this is 15 centimeters tall for the height of water of two cylinders. The graph shows how the height of the water changed as the volume of water increased in each cylinder. Which cylinder has a larger radius? So when we're talking about this, we're talking about a radius, which is going to be on the base of a cylinder, right? And if I have a small radius or a large radius, that radius is going to determine the area of the bottom of that cylinder. Now, knowing what we know about cylinders, a cylinder is a circle, a base and a top there, and then a height, right? And so when you're finding the volume of a cylinder, the volume of a cylinder is equal to the base, pi r squared, times the height. So that radius has a big effect on the overall volume here. And we can see the volume is increasing for each of them. Although A, the volume does increase more, it starts off a little less, but the volume has a greater increase as, well, the height increases and the volume increases. We can see that there. And so you can kind of imagine you have like a tall, skinny cylinder like this, right? And then maybe a round, not quite so tall cylinder like so. Okay, or maybe it's round like this, it's the same height, but the amount of water that it starts at might be lower or higher, right? And that radius is going to determine how much water can continually be put into that container, and it's going to affect the overall volume. So I'm just drawing pictures here. These aren't solutions, just kind of talking through things here. So as you read this here, think about the different types of cylinders you can think of and how that radius has an impact on what the volume is going to be. So again, just something to think about, and then you're going to write down which one you think has a larger radius, A or B, and how you know. So just give it some thought. Number two, we have a graph here, and it says it wants us to find the slope, the y-intercept, x-intercept, and the equation of the line. Alright, so our slope is going to be our y over our x, right? And so to find a point, here's a point right here. We find another point, there's a point right there. And we can see that we're going down 2, so it's going to be down 2, and the x value here is over 1. Over 1. So what are we doing? The change in y and the change in x. So we're going down 2 over 1. So our slope happens to be -2. The y-intercept is going to be where this line crosses the y-intercept, in this case, which is at point 2. So it's at 0, 2 is where the y-intercept is at, if you were to write like a point. The x-intercept is here at 1, 0. And I'm writing a little darker or lighter on purpose just so we can highlight the important numbers here. And for an equation, what's important for an equation is going to be the slope and the y-intercept. This is not important for the equation. The equation of a line is found by doing y equals m, which is the slope, times x plus b, which is the y-intercept. So we're going to plug these things in. Y is simply y. Our slope is here at -2. X stays in x. And our y-intercept is also +2. So +2 is where it's at. And that becomes the equation for our line in the graph. Okay, down below we have some just practice and review type of things. So let's look at some of these together. The first one, we have 1/3 times all of this. So the 1/3 has to be distributed to each one of these parts, right? So what we're thinking about here is really 1/3. When I multiply a number by a third is the same as dividing by 3. Okay, so multiplying by 1/3 is the same as dividing by 3. So what you want to think about is 45 divided by 3 is what? Okay, in this case here, 45 divided by 3 is 15, and we keep the x. And 3 divided by 3 is going to be 1, but it's a positive divided by a negative, so we'll have a negative 1x. I can write a 1 if you like, but I can just also write negative x, doesn't matter. And then 21 divided by 3 is going to be equal to 7. So now I want to combine like terms, and I have a 15x and a minus 1x for a grand total of 14x plus 7, and that becomes my solution right there. Okay? I'll do the same for number 4, or you will at least. Again, you're going to distribute the half, or really divide everything by 2. 20 divided by 2, negative 4 divided by 2, and 8 divided by 2. Figure that out, combine your like terms, and solve. So do that for 4 on your own. Number 5 and 6, we have two systems of equations, okay, and this is going to be a common thing you've seen throughout the unit, and you'll have more coming up here. So I'll work out one of them, and then you can try the other one, see how you do. Again, these are things you should already have done, and this is just a homework review to see how'd you do, more than anything else. Alright, so in this case here, what we're going to do is we're going to take this y value, because y equals that, and we're going to substitute it right there for that one. So we rewrite the equation as 1/3 x plus 3 equals this part, 2x minus 2, and now we're going to solve for x to find out what our first x coordinate is going to be. Because remember, the solution when we solve this is going to be a place on our graph where the two graphs come together, so we're looking for a coordinate for what that's going to be. So first we're going to find the x part. So let's go ahead and subtract 1/3 x from both sides, 1/3 x. So 2 minus 1/3. Okay, you may not quite know what that is, but 2 minus 1/3 is going to be equal to 1 2/3. All right, yeah, 1 2/3 x, and we'll leave it like that. Okay, and then we're going to add 2 to both sides. Add 2 to both sides. 3 plus 2 is 5. So now we have 5 equals 1 2/3. And you think, well, now what am I going to do? Well, let's turn this into an improper fraction. So 3 times 1 is 3, plus 2 is 5. So I really have 5/3 x equals 5. Now for those of you who started playing with decimals already, that's a bad idea. It's just easier to do this way. How we get rid of this? We multiply by the reciprocal on both sides. And notice what happens. Over here, those cancel, and I'm left with an x. And what happens right here? The 5's cancel out, and I'm left with just a 3, so x equals 3. So that's my first point. Now I need to find out what the y coordinate is going to be. So I'll take this 3, and we can plug it back into either one of these equations here. I'll just do this one right here. So y equals 2 times 3 minus 2. Where'd the 3 come from? The value of x is 3. So y equals 6 minus 2, so y equals 4. So our coordinates for our system equations for the first pair of equations will be 3, whoops, space there, sorry about that, 3, 4. Alright, and that's what we have there. Do the same type of thing for number 6 and see what you get. That's it for today, real simple. Hope you got that, and we'll see you next time.